What is voltage? Let's simplify and compare voltage to water pressure. An often used example to explain voltage is that of a water tower. The large tank of water puts pressure on the pipes below thanks to gravity. This creates positive pressure. Another example to equate voltage to is that of a syringe. As you pull the plunger back, the negative pressure it creates in the barrel sucks up whatever liquid is in the bottle, water in this case. With electricity, gravity has little effect, but negative and positive pressures on an electric circuit will cause electrons to flow through it from one end to the other, creating an electric current. A battery is a great way of introducing both negative and positive pressure within an electric circuit. In general, all batteries have the same principle. They possess two electrodes. The one on the negative side is called the anode, and the one on the positive side is the cathode. If you've seen the previous videos, you'll know that electrons flow from the negative to the positive. It is the minus side, the anode, that has a surplus of electrons and is therefore comparable to our water tower, putting positive pressure on the circuit, losing electrons. And it is the plus side, the cathode, that has a shortage of electrons and is therefore comparable to our syringe, putting relative negative pressure on the circuit, gaining electrons. Maybe this helps too. Remember, atoms lacking in electrons are positively charged, while atoms with a surplus of electrons are negatively charged. This makes the battery push and pull on the electrons within an electric circuit from different ends of the battery. All we need to do is provide a wire connection to get the electrons to the other side so they can do work on their way over there. Remember, nature always tries to return to a neutral charge equilibrium. When a battery has gone flat, as they say, nature has rebalanced the electron difference between the battery's two sides and it has returned to its neutral charge equilibrium. By the way, make sure you recycle empty batteries. To measure how much current flows, we use ampere, as explained in another video. To measure how strong that current is, how much pressure this flow possesses, we use voltage. Batteries work thanks to some ingenious chemistry, which also determines its positive and negative pressures. But if we replace our battery with a generator, the same principles apply. It too has two electrodes and puts positive and negative pressures on a circuit. Researching the topic, writing the script, designing a storyboard, illustrating, animating, recording, editing audio, discovering you've made mistakes and then doing a few things over again. Making videos is a lot of work. If you feel my videos are entertaining and or helpful, please consider helping me make more of these videos. Subscribe to my Patreon and get lots of exclusives at patreon.com/svdb. Thank you, and back to the video. For now, let's use a multimeter on the voltage setting and take a measurement at the negative and positive terminals, the electrodes of our battery. It's this difference in pressure between the anode and cathode that we express in voltage or volts. And although I've said pressure a lot so far, voltage in other words, what we are really talking about is electric potential. The word potential is important because it describes the potential amount of work this power source can provide. For instance, does it have the potential to light up an LED or light up an entire city? To illustrate electric potential or potential electric energy, think of a rubber band being pulled apart. This causes its potential energy to increase, which gets released when you let it go. A battery, power plant, or any other power source has two types of potential energy, negative and positive, because this difference needs to exist for the electrons and current to flow between the source's electrodes. The difference between these two is what we call the potential difference, which is again what we measure and express in volts. Going back to our earlier example, if the water is moved at a higher pressure, you can imagine that the water current has more power to do work. For instance, driving a water wheel. Water wheels can be quite heavy. and require a certain minimal amount of water pressure to start moving. If the water does not have enough pressure, it just trickles over the wheel without moving it. With electricity and its flow of electrons, this makes for a good enough metaphor. A 9-volt battery will not be able to put enough pressure on the electrical circuit, or rather, create a sufficiently strong enough current to power an old-fashioned light bulb, which requires 120 or 230 volts depending on where you live. The old bulb's filament's resistance is too high for the material to become hot enough to emit light using such a low voltage. But the electrons can still trickle through the material. This way, the battery will just empty itself while you stay in the dark. We will explain resistance in another video. Voltage is calculated by subtracting the electric potential of point 1 from point 2. For instance, the positive and negative terminals of a battery. In practice, however, the voltage is calculated using the energy consumption in joule, divided by the electrical charge in coulomb, which was explained in the video on ampere. Joule is a derived unit of energy, which can be calculated in several ways. For example, 1 joule of electric energy is required to light a 1 watt LED for 1 second. A typical AA battery has 9,360 joules of energy and an electric charge of 14,014 coulomb. We can now calculate the voltage by dividing the charge, coulomb, by the stored energy, joule. The result is 1.5 volts. This means a typical AA battery has a potential difference between its positive and negative terminals of 1.5 volts. This causes an electric current to flow at a certain electrical pressure, an electrical potential, to do work in devices that require 1.5 volts. Other devices might need batteries with a higher voltage to function, a more powerful power source altogether, or multiple batteries of the same type. Connecting multiple power sources in series, for example these AA batteries, increases their total voltage output. The math is simple. Connecting 3 1.5 volt batteries in series makes for a total of 4.5 volts. Connecting things in parallel does not increase their voltage output. Thanks to my patrons for making this video channel and my other channels possible. And thanks to Thijs de Bond from De Bond Amps, amplifiers, not ampere, for helping me fact check this video. And if you want more, subscribe and hit that bell to get notified when a new video finally arrives. If you think this video was helpful, please leave a like. Your support and kind comments is what keeps me making these videos. Sources in the description, and thank you for watching.